In the following video, we're going to examine an application problem on how to solve a system of equations in 3 variables. Now, this application problem is unique with how we're going to set up the 3 equations and the process used to solve. Let's start. There are 3 sections in an amphitheater. Section A, closest to the stage, Section B, and lawn seats. Seats in Section A cost $30, seats in Section B cost $25, and lawn seats cost $20. There are twice as many seats in Section B as in Section A, and when all 19,200 seats are sold, the amphitheater makes $456,600. Write and solve a system of equations to determine how many seats are in each section. So we want to find how many seats in Section A, B, and the lawn seats. So the first thing we need to do is we need to create our system. So I'm going to look for units that line up, units that match. The first thing I see is we have seats in Section A costs $30. Section B costs $25. Section C, you can call the lawn seat Section C, costs $20. So here, it looks like I'm going to let A be my number of Section A seats, B my number of Section C, B seats, and C my number of lawn seats. Seeing how my units are dollars, dollars, and dollars, I'm going to continue on and look through the rest of the problem until I start to see, when all 19,200 seats are sold, the amphitheater makes $456,600. So there is a matching unit, which means these pieces of information will be used to create the equation. So the first system is you get $30 for every Section A seat, so 30A. You get $25 for every Section B seat, so 25B. And you get $20 for every lawn seat. And like I said, I'm going to call that Section C. And if they sell so many A, B, C, they want to make $456,600. So when creating equations from a story problem, you want to make sure, and my hint is always try and get your units to match up on the left side and the right side. Look for units because it's going to help you with creating your equation. Since I had dollars, 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 I mean, there's no way it's going to add up to something that's not dollars. So I have to make my units on the other side of the equation match. So that's the first piece of information. So I'm going to now move these and kind of cover up what we just used so we can focus on the other pieces of information which we haven't used yet. So we have there 3 sections. There are twice as many seats in Section B as in Section A. So that looks like something important. There are twice as many seats in Section B as in Section A. So that means your Section B seats are going to equal twice your Section A seats. There are twice as many seats in Section B as Section A. So 2A equals B. So that used another piece of information for us. And I go through now and I see there's only one more piece of information remaining. There is a total of 19,200 seats. Well, what type of seats does the amphitheater have? The amphitheater has Section A seats, Section B seats, lawn seats, which we're going to use C for. So the number of Section A, the number of Section B, and the number of lawn seats total is 19,200. So here is my system of equations, the first part of our problem. Write a system of equations. Now the second part is to solve a system of equations to determine how many seats are in each. So solving this system is a little bit different because we don't have 3 equations with all 3 variables. In this one, we actually have a third equation that only has 2, b equals 2a. So to solve this one, what I'm going to do is I'm going to first use my substitution method. I'm going to substitute 2a in for b into both of these equations. One, that's going to allow us to kind of not focus on this, and two, by doing that, it's going to get rid of the b variable here and create an a variable, which then allows me to combine my like terms. So maybe again, if you want to call it step 1, substitute 2a in for b. And so I have for my first one, 30a plus 25b, but we see that b is actually 2a, so 25 times 2a. And then we have plus 20c equals 456,600. And in my second equation, I have a plus b, but instead of b, I'm going to use 2a, so a plus 2a plus c equals 19,200. So I used my substitution method, plugged in 2a for b, and now I'm going to simplify, I'm going to combine like terms. So if I do, and I'll do the quick math underneath, and then we'll fix it. 25 times 2a is 50a. And so if I want to create my new system from this, I'm going to have 30a plus 50a, which is 80a, plus 20c equals 456,600. A plus 2a in the bottom is 3a. So if I have 3a plus c equals 19,200. So we see as soon as I used my substitution method and plugged in 2a for b, I now created a system of equations of 2 equations and 2 variables, which means now I can use my elimination method. So we'll call it step 2, use the elimination method. And if we see we have 80 and 3, not multiples of each other, you have 20 and 1. Well, I can multiply this boundary equation by negative 20 to cancel out the c. So use elimination method to eliminate the c variable. And so I have my system. So I'll just bring it down here. And we always want opposites when doing our elimination method. It's the easiest route. So if I take a look, I'm going to multiply this bottom equation by negative 20. And that's going to allow us to get a negative 20 here, positive 20 there. It'll allow us to eliminate this c variable. So my top equation stays the same as 80a plus 20c equals 456,600. The bottom equation becomes negative 60a minus 20c equals negative 384,000 and so then we add these together. And so our 20a and our 20c and our negative 20c cancel. 80a minus 60a is 20a. And 456,600 minus 384,000 is 72,600. Divide both sides by 20. A is 3,630. And so there's our A value. Well, now that I know A, I can work backwards. I can plug it in and find C into either this equation, 3A plus C, or the equation with 80A plus 20C. I'm going to plug it back into this bottom one because they're smaller numbers, and so there's less of a chance of making a mistake. The calculations will be easier. So our third step, step 3, is to substitute A in to find C. And so we have 3A plus C equals 19,200. So we have 3A, which is 3,630. So 3 times that plus C is 19,200. And so I get 10,890 plus C equals 19,200. And subtract 10,890 and C equals 8,310. And then step 4, is to substitute A in to find B. Because if we take a look, our third equation was, hey, your B value is twice your A. And so now that I know A as being 3,630, we said our B value is going to be twice that A. So I can just take A again and plug it in. So the number of section B seats is twice 3,630. So your number of section B seats is 7,260. And again, since it's a story problem, just like we did when we were learning linear programming, we want to make sure we write our answers in context of the problem. So section A, we said is 3,630 seats. Section B is 7,260 seats. And section C is 8,310 seats. So always when you're dealing with story problems, write your answers in the context of the problem, what each variable represents. And so here is the solution. So this technique, it works in this story problem where we didn't have to do elimination 3 times. And the reason why is because we had a variable that we could use substitution with. So there's still a way to use a combination of substitution and elimination in order to solve a system of 3 equations. It depends on what your 3 equations and 3 variables to look like. And you can have problems like this using this approach that are not story problems. You just have to look at the 3 equations given to you and determine how to approach it.